So most of you have responded to it. But okay, friction is a natural winner. I am very well aware of it, right? Only twice friction has won. Okay, in number of counts of votes. So don't worry about it. Even if I am teaching friction now, I'll be sending you the recorded session of numerical solving algorithm of constraint relations in the WhatsApp group. If you're not there in the WhatsApp group, please join WhatsApp group. There, I'll send the recorded session of mind maps. Then I'll send the mind maps of constraint relation number 1, and I'll also send you the recorded session of numerical solving algorithm of constraint relations. But today, now, I'll be teaching you friction. Okay, so let's start with friction. So, so I'm starting from the very beginning. See, okay. First of all, write all your queries in your notepad or pen or notepad or paper or diary, whatever you have. You can type it here also, but I'll be answering all your queries towards the end of the session. As of now, please ask doubts related to what I am teaching you now. Okay, you are here to learn, so learn this topic. I will not leave this place until and unless I have answered all your previous queries. All your queries towards the end of the session only. Tomorrow there is an exclusively half an hour Q&A session along with your parents, so you can attend it tomorrow also. Clear? All of you understood? Ready for learning friction? How to draw mind maps, how to solve numerical, how to write numerical solving algorithms. So type BIO, bring it on. That's great. Thank you so much, kids. So what is friction? All of you. All of you. See this. Take out your 2 fingers and make your legs. Start walking with your fingers on the other hand of yours. All of you do this. Start. I'll just show it to you. Okay. Take 2 fingers and start walking on your left hand. Take your right hand 2 fingers and start walking on your right hand. And see what you are doing, what you are trying to do. See, when you are trying to walk with your fingers on your hand, right? When you want to move ahead, what you are doing is you are trying to push the base, or you're trying to push the other hand backwards, right? See? आप ऐसे ही आगे बढ़ते हो ना? All of you do this. All of you do this. That is how you learn the definition of friction. You're trying to push the ground in the backward direction, and your fingers will slide in the backward direction if your finger will slide in the backward direction if there is not enough friction. Yes or no? You have to take the support of the hand. All of you, yes or no? Type yes or no. Okay, most of you are saying yes. So your finger has a tendency to slide in the backward direction, right? So let's get back to what is the definition of friction. Okay. So see, friction is a force. So friction is a force which opposes the relative motion or its tendency between the bodies in contact. Friction is a force which opposes the tendency of relative motion or its tendencies between the bodies in contact. So I'll just draw a man here, right? So this man is trying to walk on the ground. Okay. So this man is trying to walk on the ground. This is ground. And when he walks on the ground, he's trying to push the ground. His legs will slide in the backward direction if there is not enough friction, right? So in this case, using the definition, what can you say about the direction of friction? All of you, where is this friction acting? In the forward direction, in your feet, where is the friction acting while you walk? In the forward direction or the backward direction? Type the answer. Backward or forward? Arey. Why backward? Why backward? Your leg is trying to slide in the backward direction. See, your leg is trying to slide in the backward direction. So your leg is trying to move in the backward direction. So friction will try to push it in the forward direction. Yes or no? See the definition. Follow the definition. Friction is a force which opposes the relative motion. We are not moving forward. We are moving forward, but our legs, we are pushing the ground in the backward direction. See, if there is no friction, what will happen, Bhavika? If there is no friction, what will happen? Your finger will slide backwards. Yes or no? All of you, those of you who said backward direction friction, just learn it. When you learn it, try to learn. When you are moving in the forward direction, when you are try moving with your fingers, right? If there is no friction here, what will happen? Your fingers will slide in the backward direction, right? So relative motion kahan hua beta friction ka? Sorry, fingers ka. Backwards. So your legs also do the same way. It's the relative motion of the legs are in the backward direction. So friction will act in the forward direction. All of you understood this? Type understood in the comment window if you have understood it. Okay? Very good. Very good. ठीक है. अच्छा, एक second रुको जरा. ध्येय, you are in which standard? Kinematics पढ़ा है बेटा? Relative motion? उसमें रिलेटिव मोशन आता है, चेक करना. ठीक है, आज भी बताऊंगा बट अभी वेट कर. So friction is a force which opposes the relative motion. So in this case, it is opposing the. Actually, if there is no slipping taking place, then there is tendency of relative motion, and if there is actual slipping taking place, then there is relative motion. चलो, ये एक हो गया friction का direction देखा. एक और example लेता हूं. देखो, there is a block here, and this block is kept on the ground. All of you, please pay attention. There is a block here, and the block is there on the ground, right? Now, you are trying to push this block. You are trying to push this block in the forward direction. All of you, look around in your room, wherever you are sitting there, at your home, look around yourself. Do you find a very heavy object? Yes or no? Do you find a very heavy object? Yes or no? Yes. Go and try pushing it. Push it lightly. Go and try pushing it. हाँ, go and try pushing it. Very lightly. जल्दी आओ push करके उसको. On a count of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done? So were you able to push it? When you pushed it lightly, were you able to push it? Did it move? Did it move? No. Right? So what happens is, now imagine if whatever object was there, that object is in air, and if you push it slightly also, then that object will start moving. So in your case, when you were trying to push the heavier object, that was having a tendency to move. Though it was not moving, but it has a tendency to move in the direction of force applied. So in this case, I am applying some kind of force on this block, and this block is very heavy, right? It's a very heavy block. So, and this block, I am not able to move this block. So what happens is there is a friction which is opposing this block. So this block has a tendency to move in the forward direction, right? And so friction is opposing this tendency of its motion. That is what I call as relative motion. Its tendency. Okay, this is the key word here. It opposes the relative motion. It opposes the relative motion or the tendency of relative motion. Right? Now, what happens if we start pushing it with much strength, much more strength? What will happen? This block may move. Right? This block may move. And then there is actual slipping between the body and the floor. then there is actual slipping of the block on the floor, right? Then also the friction will act on the opposite direction. How many of you understood relative motion of the block? When block starts moving with the ground, then block is relatively moving with respect to the ground. Understood, all of you? Very good. Type understood if you have understood it. That's great. So friction opposes the relative motion or its tendency between the bodies. Please remember the most important word here is relative motion. Friction will not always oppose the motion of an object. It will not oppose the motion of an object always, right? It will oppose only the relative motion or its tendency. That's it, right? Friction is also the horizontal component of reaction force. Now, what is this? Just pay attention. So I have this block here. So this is the block, and I have enlarged it. We are seeing it under microscope, right? So here there is this irregularity at the bottom of the block. There is this irregularity at the bottom of the block, right? Now this block is kept on a surface. This block is kept on a surface. Okay? Please check. On the table it has been kept, right? It is kept on a table. And this is how you can see that there is interlocking of the irregular surfaces, right? And then there is also this bonding taking place, right? Bonding, interatomic bonding between the atoms of the bottom of the block and the top of the ground, or the top of the table or surface on which the block is kept. Now, because of these two, please pay attention and listen to me carefully. Because of these two, what happens is there is a force here which is exerted by the table. There is a force here which is exerted by the table on the block. ठीक है? Table ने block के ऊपर एक force लगाया है. And this force is called as reaction force. This force is called as reaction force. How many of you understood this? Any doubts here? Any doubts here? If you have understood it, type understood. Okay. See, please respond. Please participate and respond. ठीक है? समझ नहीं आएगा तो भी समझाऊंगा मैं. हाँ. देखो. किसी ने कहा है रिपीट करने के लिए, मैं रिपीट भी कर देता हूं. ठीक है? Okay. Okay. See, there are surfaces which, if you see under microscope, they will be irregular surfaces. Yes or no? If you see the surfaces under microscope, it will be irregular. Yes or no, all of you? Yes, very good. Now, what happens when you keep two surfaces over each other, right? There is this interlocking of the irregular surfaces. Clear? And there is also the bonding happening place. The bonds of the atoms of the bottom surface of the block here and the atoms of the blocks on the ground. They start making bonds between them. They start getting associated with them because bonds are electrostatic forces, right? So they start attracting towards each other, or they start making connection between each other. Simple. Isko aise hi samjho abhi. So because of this, what is happening is there is a force which is exerted by the ground on the block and by the block on the ground, following Newton's third law. By the ground on the block, this black color is by the block on the ground, and this blue color is, dark blue color is by the block on the ground. So this force is called as reaction force. ये इतना ही simple है. ठीक है? इससे ज्यादा की जरूरत नहीं है किसी को भी. Clear? Now, these are the two perpendiculars or XY planes, you can say, XY lines, you can say, axis, you can say, right? This is X and this is Y. Sorry, this is X and the other one is Y. Now you can see here that the component of this force is, the vertical component is this one. And this is called as normal reaction N. This is called as normal reaction N. All of you understood this? Quickly, yes or no? And there is this horizontal component, and there is this horizontal component, which is called as friction. There is this horizontal component, which is called as friction. All of you understood this? Yes or no? Very good. So this is lambda. This is lambda. That is the angle between reaction force and normal reaction is called as lambda. And this lambda is called as angle of friction. So friction is, the second definition of friction is, you can also explain friction by saying that it is the component of reaction force, horizontal component of reaction force. Right? Yes or no? ये इतना पार्ट समझ आया या नहीं आया सबको? लिखो, type yes or no, all of you. Please type yes or no. Wow, that's great. So now comes to, so definition part is over. I'll explain relative motion, don't worry about it. Okay? Now we have three different types of friction here. Okay, we have three different types of friction here: static friction, kinetic friction, and rolling friction. Okay. Remember the example which I just gave you, pushing the heavy almirah. There that the friction which was acting there was static friction, right? So it opposes the tendency of relative motion. It opposes the tendency of relative motion. Number one, bodies are at rest with respect to each other. When you are pushing the almirah, what happened was the almirah was at rest. Yes or no? With respect to the ground. So bodies will not slide over each other. Yes or no? All of you type yes or no. Wow, that's great. And it is self-adjusting. So I'll try to explain this to all of you. Okay. I'll try to explain this one to all of you, how it is self-adjusting. Please pay attention, all of you. So I have this block here. And this block is kept on the ground. ठीक है बच्चों? Now, so it's very simple. ठीक है? And see, why I am showing you using mind maps is how you can draw on your own. So this is a force here. And there is a friction. So friction is always given as, the maximum friction is always given as Fs max. The static friction is always given as, first of all, it is proportional to normal reaction, right? And it is equal to, the proportionality constant is equal to mu s for maximum static friction, right? Now, what is this mu s here? Mu s is coefficient of static friction. ठीक है? Coefficient of static friction. Please pay attention here. The mass of the block is 2 kgs, right? So 2 kg, 2g is the force acting downwards. Normal reaction is acting upwards. This is N, right? And in this case, what will be the direction of friction in this case, all of you? Just now we have discussed it. What is the direction of friction, forward or backward? Backward, right? Very good, very good. Shabash beta. So we have, this is the direction of friction. So friction F is equal to what? Fs max is equal to what? You are aware of N minus 2g is equal to 0, right? So what is normal reaction? It's 20 newtons. Okay. Mu here is, the coefficient of friction, static friction here is 0.2, right? So what is Fs max? It's mu s into N. That is 0.2 into 2g. Take g as 10 newtons. Sorry, 10 meters per second square. So this is 4 newtons. Right? Normal reaction. N upwards, 2G downwards, clear. Capital F in the forward direction, friction in the backward direction. Right? So Fs max is proportional to N and the proportionality constant happens to be mu s. So N minus 2G is 0, N is 20 newtons. Using Fs max is equal to mu s N, we get 0.2 into 2G, that is 4 newtons. All of you understood this or not? Just type understood in the comment window. प्लीज टाइप हाँ सी मैं पढ़ा रहा हूं देखो तुम भी अपना टाइम इन्वेस्ट कर रहे हो मैं भी कर रहा हूं ठीक है तो वी शुड लर्न इट राइट ठीक है यस नाउ सी दिस if f is 0 now acha okay just let me know this if f is 0 what will be the value of this static friction is this will this object move अच्छा चलो इसी को समझाते हैं रुको जरा एक सेकंड कौन है ये नाम क्या है इसका ध्येय एक बात बताओ ध्येय अगर एफ कैपिटल एफ की वैल्यू 0 है तो एफ एस 0 होगा या नहीं होगा बोलो हाँ या ना ऑल ऑफ यू प्लीज रिस्पॉन्ड ऑल्सो ठीक है ओके सो दिस इज 0 नहीं नित्या इट विल नॉट बी पॉइंट नहीं दिस इज नित्या जी इज 10 राइट जी इज 10 ठीक है Now, when f is 1, what is the maximum value of Fs max? It's 4 Newton. So now it will take 1 Newton. There, yes or no? All of you, yes or no? Type yes or no. If f is 1, Fs is 1. If f is 2, Fs is 2. If f is 3, Fs is 3. If f is 4, Fs is 4. All of you. There, समझ आया नहीं आया? Very good. Now when this capital F exceeds 4, when this capital F exceeds 4, what will happen? The bonds, they will break. The bonds, they will break, right? The uneven surfaces, they will break. The grooves will break, right? And the block will start moving forward. The block will start moving forward. So that is then comes kinetic friction. So as of now, what happened here was the value of Fs. Please pay attention, all of you. As of now, what happened here was the value of Fs was varying between Fs max to 0. Clear hai? All of you, yes or no? And that is why Fs is a self-adjusting force. Static friction is a self-adjusting force. ठीक है बेटा सबको समझ आया है आप लोगों को wow that's great now if you draw the now उससे तुम्हें कोई मतलब नहीं है थे it is given ठीक है mu s is given it's different for different pair of surfaces now if you draw just pay attention huh if you draw the graph between F and capital F, right? Now, acha, 1 minute, huh? So till this 4 newtons, it was at rest. Now, when capital F exceeded Fs, there is some different mu k now. There is some different. The object will start moving and we say that the kinetic friction starts acting here. Right? So the direction of kinetic friction is also same. In place of Fs, there will be Fk now. The value of Fk is again proportional to N and the proportionality constant is mu k. This is coefficient of kinetic friction. Okay. And when you solve for it, it's 0.18 into 2G and that is 3.6 Newton. Always remember mu K is slightly lesser than mu S. This is found experimentally, right? Mu K is slightly lesser than mu S because the same number of bonds, the same kind of intense interlocking doesn't happen when the objects are unmoved, right? So that is where the block started moving. So the objects will start moving over each other. Clear hai sabko ye? All of you understood this? Yes or no? So when you draw the graph between, please pay attention. When you draw the graph between F and Fs, capital F and friction, this is how the graph looks like. This is how the graphs look like. This one is kinetic friction and the dark blue one is static friction. Okay. This is Fs max and this is Fk. Fs max is 4 Newton. Fk is 3.6 Newton in for this case, right? Whatever case we have done now. And this is, sorry, this one is 4 Newton here. The applied force, right? This applied force is 4 Newton. Can anybody tell me the angle which this line is making with the horizontal? Anybody? All of you, just tell me the angle between these two lines. What is this theta? Very good. It's 45 degrees. Excellent. Now, how 45? When capital F was 1, this was also 1. When capital F was 2, this was also 2, right? That's why this angle is 45 degrees. I hope all of you understood this. Tan theta is equal to base upon perpendicular. ठीक है? चलो, good. So, ये भी देख लिया, ठीक है? So let's go back to our mind maps. What did we say here? Static friction opposes the tendency of relative motion. The bodies are at rest with respect to each other. It is self-adjusting. All the relevant points are written here. All the relevant points are covered. And then what about kinetic friction? Opposes the relative motion. Opposes the relative motion between two bodies, right? Bodies move with respect to each other and Fk is equal to mu kn. All the relevant information is here, right? Rolling friction is what we will study only in rotational mechanics. So as of now, no, we will not be talking about it in great detail. But all of you understood static and kinetic friction. Type crystal clear, CC, type CC if you have understood it. Very good. Excellent. Shabash. So you can take a screenshot of it. Right? Now comes how to find direction of friction. How to find direction of friction. Now these are some easy, simple steps which I am showing you and we will follow that also. Okay, I'll show that to you. So how to find direction of friction. Step 1. Step 1. Step 1. Separate the surfaces in which you want to see friction from each other. Separate the surfaces from each other, right? In which you want to see the friction. Second is observe the relative motion of each surface with respect to the surface with which it is in contact. Okay, I'll explain this to you. Don't worry, I'll explain this to you. So we have this thing here. So this is a blue block, an orange colored block, and a green block. ठीक है बेटा? Please pay attention. I am showing you how to find direction of friction here. It's a 3-block question. Usually it is taken as difficult questions. These are considered to be difficult questions, but I am showing you a very easy way to see it, right? See the direction of friction. So in this case, what is happening here is this block, this is block A, this is block B, this is block C. The block A is pulled in the forward direction. Block A is pulled in the forward direction using a capital F force. Here the friction coefficient is mu1, here the friction coefficient is mu2, and here there is no friction. All of you? Or likh lo isko, koi baat nahi. There is friction here also between C and the ground. So where is the friction acting? In how many surfaces is the friction acting? 1, 2, 3, 4, 5. In how many surfaces the friction is acting? Type the number of surfaces in which the friction is acting. Type it. Please be quick. Please be quick. Wow. Excellent. Shabash beta. Thank you so much for response. Thank you so much for your quick response, right? Okay. Now I'll show it to you. Please pay attention. Now your time is done. Please pay attention, all of you. ध्यान से देखो बेटा. ठीक है? Now, friction is acting at bottom of A. Friction is acting at bottom of A, top of B, bottom of B, top of B, bottom of B, top of C, bottom of C, and there is also a ground here, right? So here at the top of the ground also. So how many surfaces? 1, 2, 3, 4, 5, and 6. Understood? Type understood. All of you convinced with 6 surfaces? Great. Excellent. Excellent. Shabash. Very good. Very good. So now, ab dekho how to see the direction of friction. Please pay attention. We can solve enough good problems, so don't worry about it, right? There will be many examples. So now, first is identify the object on which external force is acting. Here, capital F is acting on the top block, right? On block A. So where do you want to see the friction? We want to see friction at bottom of A. Bottom of A is connected to which surface? Bottom of A is connected to which surface? Type your answers. Top of B. Bulikor. Top of B. Sorry. You please excuse me for my bad throat. Huh? I was just suffering from too bad cough and cold. So now stand on top of B. Stand on top of B. And see where will A move? In the forward direction or in the backward direction? Stand on top of B and check where will the block A move? Forward or backward? Forward. So now you are aware friction opposes the relative motion. सुनो ध्यान से. ब्लॉक ए बी के रिस्पेक्ट में फॉरवर्ड मूव कर रहा है, इसका मतलब रिलेटिव मोशन हो रहा है ए का बी के रिस्पेक्ट में. समझ आया? जब दो ऑब्जेक्ट्स एक दूसरे के रिस्पेक्ट में मूव करने लगते हैं उसको रिलेटिव मोशन बोलते हैं. ध्येय समझ आया? ये रिलेटिव मोशन होता है बेटा. तो आपको ये देखना है कि ए, वेयर इज ए मूविंग, राइट? तो ए इज मूविंग इन द फॉरवर्ड डायरेक्शन, सो फ्रिक्शन विल एक्ट इन द बैकवर्ड डायरेक्शन. This is the direction of friction acting on the bottom of A. How many of you understood it? Type CC if it is clear to you. Very good. Very good. Now, the next surface where we will see the direction of friction is the top of B, right? Here. Remember yesterday's Newton's third law? Every action has an equal and opposite reaction. Remember or not? And the action-reaction pair acts on different bodies. So here, the reaction force of this F1, if this F1 is action, the other F1 acting on the top of B will be reaction force. Clear or not? This is the direction of friction on the top of B. Understood or not? Please type understood. That's great. Very good. Very good. Understood, all of you? Wow. Now, the third surface is bottom of B. The third surface is bottom of B. Again, stand on. You bring your miniature on the top of C. Bottom of B is in contact with top of C. So what will be direction of motion of B with respect to C? What is the direction of motion of B with respect to C? Because of this F1, B is moving in the forward direction. Yes or no? Yes. So friction will act in the backward direction. Understood all of you? F2. Clear? And again, action-reaction force. This is again F2 in the forward direction. Equal and opposite, right? Now again, at the bottom of C, you want to see friction at the bottom of C, right? Here. So bottom of C is in contact with the ground. So stand on the ground now. C is moving in the forward direction. So friction is acting in the backward direction. Understood or not? Yes or no? All of you. Please type yes or no. Wow. And the last one is the friction on the top of ground will act in the forward direction. This is F3. All 6 clear. ASC. Type ASC. All 6 clear. Please type it. There are many students here. Please type it. Thank you so much. We should appreciate our efforts of the time. We should appreciate our time we have invested and efforts, right? Excellent, kids. Excellent. Now I'll tell you. See, this is how we draw that. We find the direction of friction. And I have given this in very lucid, very easy 4 steps. Separate the forces, surfaces. We separated it. Observe the relative motion of each surface with respect to the surface with which it is in contact. We saw that. Friction will oppose this relative motion. Plain and simple, flat, khatam. It is irrespective of static or kinetic friction. Agreed? Take a screenshot of it on a count of 3. 1, 2, and 3. That's it. Thank you so much. So now let's see how to solve the questions on friction. This is numerical solving algorithm. Last one was mind maps of basics of friction. This is now the numerical solving algorithm. Okay. Chalo. So we have, I'm just switching to this place. So we have these 2 blocks here. Please pay attention. I'm doing it quickly. I'm taking some current data also, which we have already done. So don't worry on that part, right? Calculation part. We'll save time on that. So here what is happening is the friction coefficient here is 0. The friction coefficient between the orange block and the ground is 0. And friction coefficient here is mu s is what? Mu s is 0.2. Mu s is 0.2. Now we are applying a force. Capital F is equal to 10 Newton here on block of mass. This block has mass 2 kg and this block has mass 3 kg. Right? What we want to do is find the acceleration of both the blocks. Okay? All of you are clear about the objective of this question, yes or no? All of you are clear about the objective of the question, yes or no? Yes or no? Great. Excellent. So now the first step. Draw the free body diagram of each of the blocks taken separately. Draw the free body diagram of each blocks separately. All of you draw it. Try drawing it, all of you. And please cross check with me. This is 2G downwards. This is capital F forward. Direction of friction will be in the backward direction. Normal reaction exerted by the ground on the block will be in the upward direction. This is normal reaction in the downward direction. This is friction in the forward direction. This is 3G. This is normal reaction in the upward direction. And this is 3G in the downward direction. I'll write the forces also. This is capital F. This is friction. This is N1. This is 2G. This one is N1. This is 3G. This is friction. And this is N2. All of you understood this or not? Step 1 done. All of you understood this or not? Step 1 done. Now it's time for step 2. Find Fs max. Find Fs max. So what is Fs max? All of you are aware it is mu s times normal reaction. So what is the normal reaction here for Fs? This is the normal reaction, right? So mu s is what? 0.2. N1 is what? It's N1 minus 2G is equal to 0. So N1 is equal to 2G or 4 Newton. Clear? So it is not 4, this is 20 newtons. So this is 4 Newton. Clear with this? All of you, please say clear or not. Very good. CC, type CC. Yes. Very good. Wow. So step 2 done, right? Now it's about step 3. Let's see what is that step 3. So method 1. So it is step 3.1. So this is assume all the blocks together in one system, right? And find the common acceleration. We'll do 2 steps at a time, 3.1 and 3.2. Assume all blocks together in one system, find the common acceleration. This is method 1. Okay. So here we are. We have this 2 kg block and we have this 3 kg block and we are taking them together, right? Please pay attention. We are taking these 2 blocks together. Okay. And the force is in the forward direction. So this is the capital F force, which is 10 newtons. Since we are taking them together, they will have a common acceleration A. Since we are taking them together, they will have a common acceleration A, right? So capital F is equal to, what is the mass of the system? 2 plus 3 is 5, right? So it is 5 into acceleration A. So this is 10 is equal to 5 into A, or from here we get A as 2 meters per second square. All of you understood this? Yes or no? Type yes or no. You got this 2 meters per second square or not? All of you. Okay, very good. Shabash. Okay. So that is 3.1 and 3.2. So this was 3.1. This is 3.2. Now let's see the other 2 points first. So third one is check for the friction acting at each surface. Okay. Check for the friction acting at each surface for this acceleration. For this acceleration. What is the acceleration here? We got this acceleration, right? 2 meters per second square. So if you see this 3 kg, if you see this 3 kg block, this friction is responsible for this acceleration of the block. Yes or no? Yes or no? Excellent, excellent. So we have this F is equal to 3 into acceleration A. So that is 3 into 2, or it is 6 Newton. And this was static friction because the objects were not moving with respect to each other. We assumed it that way, right? Kids, say yes or no. So this is 3.3. Right? Now let's see the next step. Let's see the next step. If it is less than maximum friction, then our assumption is correct. If it is less than maximum friction, then our assumption is correct. So let's check whether it is less than Fs max or not. Check for this, all of you, check for this. Is this Fs less than Fs max? Yes or no? What was Fs max? 4 newtons. No, right? So is it correct or is it wrong? If it is not correct, then what is it? It's wrong, right? So our assumption is wrong. Now what to do next? Let's go to 3.4. See this 3.5, sorry. Fourth we have done. If the friction between the blocks is greater than maximum, read it very carefully, very slowly, read it. If the friction between the blocks is greater than maximum, then our assumption is wrong and there is relative slipping at that surface. That is, the object will slide over each other. Clear? Clear? Point fifth. Say yes or no. Is it clear? Fifth point. What is happening here? Good. Okay. So let's write. This was, we checked it. So this was point 3.4. Okay. Now we have 3.5. So the blocks are sliding over each other now. For that, I'll draw this free body just for the sake of helping you in clarity, right? This is capital F. This is Fk now, kinetic friction now, right? This is kinetic friction Fk. This is kinetic friction Fk, and this is capital F. Okay. A will slide over B. So this will have a different acceleration A1. This will have a different acceleration A2. See, almost all, when I remember this always, Fk is close to Fs max, very close to Fs max. So whenever Fs max, Fk is not given to you separately, you can use it for with approximation, right? So for this block, the force equation is net force in the forward direction, capital F minus Fs max. Why minus? Because it is acting in the opposite direction. So that is Fk here, right? Is equal to 2 into A1. When you solve for it, you get 10 minus 4 is equal to 2 into A1. So A1 is how much? 3 meters per second square. Now what about force equation for this one? Fk is equal to 3 into A2. What was Fk? It's 4. So it is 3 into A2. What is A2 here? It's 4 by 3 meters per second square. बच्चों समझ आया नहीं आया? All of you. Crystal clear? All the steps? Do you find these steps simple and useful to solve these type of questions? Yes or no? We'll solve one more question. Write it quickly. Copy it. Or just what you do is take a screenshot of it. Take a screenshot of it. This entire page. On a count of 5. 1, 2, 3, 4, and 5. And now what you do is just go through every step and please check what we have done here. And if you find any doubt in any of the steps, just ask me, I'll clear for you. I'm giving you 1 minute to do it. Only 1 minute. Do it, do it, do it. Okay. So done, all of you. Crystal clear. CC. Type CC if you don't have any doubts. Or type no doubts. Chalo, chalega. अच्छा, N1 downward on second block Y. जिसको भी laws of motion नहीं आता है, third law, every action has an equal and opposite reaction. तो एक्शन का रिएक्शन पेयर है. ठीक है रंजन, प्रकाश रंजन. इफ दिस N1 इज अपवर्ड्स, इसका रिएक्शन कहां होगा रंजन जी? प्रकाश जी बताइए. डाउनवर्ड्स. चलो शाबाश. नाउ लेट्स डू इट फॉर अ 3 block system. I'll show you. Should this, we will repeat the same step for 3 blocks. Check. ठीक. So we have these 3 blocks here. and this is it, right? Pay attention, all of you. So this is 2 kg, this is 3 kg, this is 7 kg. We have a force here, capital F, which is 10 newtons. Okay. Then there is this mu here, 0.2. There is mu here, 0.3. Clear? And there is no mu here. There is no friction here. Mu 3 is 0. Let's draw. First of all, let's find the direction of friction here. Please pay attention, all of you. Please pay attention. Draw the free body diagram of all the blocks and draw it quickly. See how to find the direction of friction here. Capital F is acting here, right? How many places the friction is acting? How many places the friction is acting? Bottom of A, top of B, bottom of B, top of C. That's it. There is no friction here. No friction here. Right? So bottom of A. For bottom of, so where is the force acting here? On second block, right? Where is the force acting here on second block? The external force. So we want to see the friction at these two surfaces now. Top of B and bottom of B. Please pay attention. So top of B is connected to which point? Bottom of A. So stand in the bottom of A. Stand on the bottom of A. And see, where is this B going? Forward or backward? All of you. Where is this B going? Forward or backward? Type. Where is this B going? Forward or backward? Forward, right? So friction will act in the backward direction. Similarly, stand on top of C. See where is B going? Forward. So friction will act. The second friction on the block B will act in the backward direction. That's it. So we have F1 and we have F2 here. Right? Here F1 will act in the forward direction. And on the top of C, it will act in the forward direction. That's it. Action ka reaction pair. Okay. Now, this is 2G. This is N1. This is 2G. This is N1. This is N1 in the downward direction. This is N1 in the downward direction. Right? This is N2 in the upward direction. And this is 3G in the downward direction. I hope all of you are clear in this free body diagram till now. Now this is N2 in the downward direction. 7G in the downward direction. And N3 in the upward direction. Normal reaction exerted by the floor on the 7 kg block. This is 7G downwards. Right? Now, please pay attention. N1 minus 2G is equal to 0. So N1 is 2G. For this block, for 2 kg block, downward force N1 plus 3G. Upward force N2 minus N2 is equal to 0. So N2 is N1 plus 3G. What is N1? 2G. So this is 5G. Right? Now what about F1 max? Find F1 max. F1 max is how much? F1 max is how much? It's mu 1 times N1. So this is 0.2 into 2G, which is 4 newtons. F2 max is how much? It's mu 2 into N2. That is mu 0.3 into 5G. This is 15 newtons. All of you. Agreed or not? Understood? Very good. Very good. Shabash. So now, step 1 of 3.1, right? For acceleration, we have to find common acceleration of all the blocks. Right? What we do here is we take all the blocks together. What we do here is we take all the blocks together. ठीक? then there is this common force acting on it in the forward direction. All the blocks will move because of this only. So this is 10 newtons ka force. They have a common acceleration A. Pay attention. 10 is equal to, what is the total mass of the system? 237, that is 12. A. What is A? It's 5 by 6 meters per second square. Clear, all of you? Just type yes or no. Yes. Very good. Shabash. Now, how to check it? Find the value of F1 and F2 for this acceleration. So you can find F1 from this diagram. You can find F1 easily from here. And you can find F2 easily from here. Right? Only force acting in the forward direction on 2 kg block is F1. So that is 2 into 5 by 6. What is it? It's 10 by 6. Is it less than F1 max? Yes or no? Is it less than 4 newtons, which is F1 max? Yes or no? All of you? Yes. Yes. So 2 kg and there is 2 kg and 3 kg will move together. Correct hai ye. Then what about F2? It's 7 into 5 by 6. F2 is responsible for this. So it is 35 by 6. Approximately 6. It is less than F2 max. Yes or no? Which was 15 newtons. So now, my dear students, 6 Newton is less than 15. So F2, these two will also move together. Clear? Since F1 and F2 are less than F1 max and F2 max, we can easily say that all the system, the 3 blocks will move together. So our assumption that the 3 blocks move together is clear. I followed all the steps. I drew the free body diagram individually. I found out F1 max, F2 max. I chose that all the blocks, 3 blocks will move together. I found acceleration. I cross-checked it. All of you, understood or not? Done with all the steps or not? See, initially it may seem overwhelming to you. Initially it may seem, yeah, why we are taking so much time? But believe me, if you follow this for next 10-20 questions, your concept clarity in this topic will be just awesome. It will be just awesome. Hoga hi. Right? So please remember this. ठीक है? Take a note of it. Take a screenshot of it. And for tomorrow, solve at least 5 questions before joining tomorrow's session. Tomorrow's session is based on test taking strategies. Right? I'll teach you a simple test taking strategy using which you can score more than, you can improve your score by at least 25%. Okay? So don't miss on tomorrow's session. But before that, you need to send me 5 questions based on this. I'll share my personal number with all of you. Please do it. Then only you will be benefited from it. Or else not. Yeah, each block has 5 by 6 meters per second square ka acceleration. So now my question to all of you is, how many of you really think that if you learn using mind maps, your efficiency to learn, retain and retrieve will be much better than what it is now? Type your responses if you really think this way. We have drawn the mind maps, right? It was very precise. It helped you. Okay, that's great. Thank you so much for your overwhelming answers. That using numerical solving algorithm will save you a lot of time in exams and improve your accuracy. Type I in the comment window if you really accept this fact. It's a fact, right? Believe me, if you work out these things in 10 to 20 questions, see 90% of friction is block diagrams. एक चैप्टर पूरा हमने कितनी देर में तैयार किया? मैंने शायद तुमको 45 मिनट्स पढ़ाया होगा अभी. 45 तो नहीं, 1 hour, right? 1 hour पढ़ाया है पूरा. 8:15 I started teaching. अभी ठीक है. And there is a lot more to know about the implementation of Physics Pro model. I'll teach you about how to implement this model, right? Any one of you. So do you really think that there is a lot you need to know? Okay, Nitya, I'll show you the mind maps. Don't worry. Just a second. This is the numerical solving algorithm. Method 2 is what we did in the 3.5 step. Take a screenshot. 1, 2, 3, 4, and 5. Tick. Then this one. 1, 2, 3, 4, and 5. Done. Tick. So let's see. Yesterday, I have already shown this in great detail to all of you. The solution to all the problems is the Physics Pro model and its 3 secrets. The 3 secrets. Some of you asked me what you will do in first 4 months. So that is where this is what I teach, right? We did the entire. How many of you have done this chapter friction in your respective coaching institutes? Whenever you will do it, believe me, they will take more than 3 to 4 sessions to teach you this topic. To help, if you are able to understand it. You just check, cross-check, right? So there is learning here. Learning through the Physics Pro model is I will help you cover 80% of the syllabus if there is constraint of time. If there is a time constraint or if there is less time and I am able to do only 80% of the syllabus, I will do it with 100% efficiency. But in your case, I'll be covering more than 100. I'll be covering 100% syllabus. Right? The learning in the Physics Pro model is more of knowledge processing than of information gathering because it uses mind maps. And you have seen the power of mind maps today. The assessments are conducted to facilitate the continuous and comprehensive learning. Every week there are 2 tests, one on Wednesdays and the other ones are on Sundays. And every student has a right to ask me the doubts of those tests. You send me the screenshot of it, I'll send you the solutions. We can discuss it. Secret 2 is feedback. We regularly keep on sharing the feedback with the students because feedback is must, right? Based upon the test scores, the students are suggested methods to improve their performance. We regularly talk to them, customize tests based on student shortcomings, group individual counselings based on the performance in the tests. I regularly talk to my students and I am the teacher in this batch, right? So secret number 3 is assessment, primarily in the form of testing. This is what we do. We conduct close to 80 tests per year with almost 100% doubt solving of difficult questions. Improves your time management skills. Why so many number of tests? It improves your time management skills, builds your confidence, it reduces your anxiety. It helps in developing test-taking strategies. You will learn some of the test-taking strategies tomorrow also. Okay. Now the secret is what? It is the balanced approach. Usually what happens is close to 80% of the time in coaching institutes is spent in learning. As I told you today, that thing which you have learned today, they will teach you this in at least 2 to 3 sessions. 2 से 3 घंटा 2 से 3 क्लास लगाएंगे, that too of 2 hour session, 1.5 or 2 hour session. आप करके देखना, आपके स्कूल कॉलेज में होगा ये, ठीक है? The balanced approach is, हाँ, if they will teach you to the extent that you have understood it, right? The balanced approach is we spend close to equal time in each of the sessions. We spend enough good time in feedback. We spend enough good time in teaching the students. We spend enough good time in giving them the feedback. Assessment, feedback, or learning. Tino mein we spend close to equal time. Assessment, I value it 1% more than others. Very simple. Just listen to what this kid has to say. This is Siddharth Agrawal. Just listen to what he has to say about his experience with my classes.
For Siddharth, इतने दिन रुकने की जरूरत पड़ी? See, this is why. See, ये जो switch है ना तुम्हारा, ये काफी देखो बहुत कम समय में what you have achieved, right?
Yes. Actually, मुझे ऐसा लगता था कि मैथ्स मेरा फेवरेट सब्जेक्ट है और उसमें मुझे सब आ भी रहा है, बट फिर भी सब कॉन्सेप्ट आते, बट फिर भी नंबर नहीं आते. सो वेयर एम आई लैकिंग? मुझे एक्चुअली करना नहीं था ट्यूशन, क्योंकि आई थॉट मैथ्स वाज ऑलवेज माय स्ट्रांग सब्जेक्ट. लाइक प्री-आरएमओ के टाइम से कि मैथ्स से मुझे पता है, उसमें ट्यूशन इट वाज लाइक काइंड ऑफ एन ईगो थिंग. उसमें मैं गलत था कि नहीं लेना चाहिए, मुझे तो आ जाना चाहिए खुद के, बट नहीं हुआ वो, क्योंकि थोड़े कॉन्सेप्ट थे जो आई थिंक बिना टीचर के मैं समझ नहीं पाता था.
So what was the best part of our association? How you benefited from our association?
Mainly जो मैं पेपर सॉल्व कर रहा था उसमें मुझे जो भी डाउट्स आ रहे थे, लाइक हर पेपर में कुछ 7-8 डाउट्स तो थे ही और थोड़े रॉन्ग्स, तो वो करेक्ट कैसे करना है और कौन सा कॉन्सेप्ट इसमें लग रहा है जो मुझे आता नहीं अब तक, या ये एडवांस्ड है तो कैसे करना है इसे सॉल्व, उसमें बेसिकली आपने काफी मदद की।
That was the best part, right? तो जब जेई का रिजल्ट